We're going to begin our journey in a state that is very near and dear to my heart. Tennessee is famous for a lot of things. Jack Daniels, various forms of country music. It also happens to be where I went to high school and where my family lives currently. There are approximately 285,000 high school students in Tennessee. How many of them do you think are taking the AP Computer Science exam every year? Yeah. The answer in 2013 was 251. So that is less than 0.1% of folks who are in high school in Tennessee. Using these stats to motivate the rest of this conversation. Hi, everyone. My name is Jessica McKellar. I am a director for the Python Software Foundation, which is the stewarding organization behind language and community, engineering manager at Dropbox. And we're going to talk about teaching the next generation of Python programmers and computer programmers, computer scientists generally. So a few more statistics for you. First off, lots of people love talking about the fact that we want everyone to learn how to code. Everyone from basketball players to really wealthy billionaires to the president of the United States, everyone would like our students to all learn how to program. But when you start looking at the data, there's a real gap between the excitement over this concept and what plays out in classrooms across the United States. So for example, here is a graph of the participation in all of the AP classes, the advanced placement classes, for 2013. This is number of test takers on the x-axis, and then sorted by popularity. And there's some classes at the top. A lot of people, 4 years of language is required, and you're in your fourth year, you would take the AP language class, fair enough. But as you start moving down this list, we see that computer science A, keeping in mind they got rid of the harder class, computer science AB a couple years ago, computer science A is narrowly beating out studio art 2D design in terms of popularity in the APs. So orders of magnitude between the most popular classes and this class that we think everyone, or we say that everyone should have an opportunity to experience. And this hits home very personally for me because while I have since graduated, I have a younger sister, who is a senior in high school this year in a public high school in Nashville, Tennessee. It's a very good school. It's an international baccalaureate world school. But her reality, she's a great candidate for a computer science class. She loves math. She's a math tutor. She loves electronics. This is her soldering a radio kit, which we did together over Christmas. Her reality at this excellent school is that these are the closest classes that she can get to a programming class. There is no concept of programming or computational thinking in her school. The closest she can get is learning how to use the Office suite. And her reality is unfortunately still the common reality. So we can do the math on this. If we use AP Computer Science as a proxy for schools that have programming classes, and this is a good proxy because we can dig at other pieces of data that indicate that schools are unlikely to teach programming if they don't also teach APCS. So if we use APCS as a proxy, we can know how many schools there are. This is publicly documented. We have a less than 10% upper bound on students who or schools that give students access to programming classes. So this is in 2013, sort of our most recent data, still the state of the world, even though we're saying that every kid should have an opportunity to learn how to program. So it's sort of depressing. Unfortunately, it actually gets more depressing. So in Tennessee, as we know, last year, 251 students took the exam, and about 165 passed, for a pass rate of 66%. This is actually pretty normal. Passing the AP exam is definitely not a given for most subjects. But here's what is a problem. The pass rate for African American students was less than half the pass rate for globally, or for all students in Tennessee for the exam. So we're starting to see a divide here in participation and in success. In fact, there are entire states where no African American students took the exam. There are states where no Hispanic students took the exam. There are states where, despite being roughly 50% of the population, no girls took the exam. So if you're a girl in one of these states and you're thinking that you might want to pursue computer science, you have to live with the reality right now that you might literally be the only person taking that exam. You better pass, right? Otherwise, you're a statistic. And the reality here is actually that computer science is the most gender-skewed AP class that there is. Now, this is a fascinating graph for a lot of reasons. What this is plotting is the log of the female to male ratio of test takers. So bars that go to the right mean there are more women taking the exam. Bars that skew to the left mean more men. And we can make a bunch of observations here. There are actually more classes where more women take the exam than men. But the classes tend to be in non-science. They tend to be soft sciences or in the humanities. As soon as we start getting into calculus and chemistry and physics, and then worst off computer science, these sort of classes that correlate to the skills that we keep talking about wanting to give people for STEM job readiness, there's a tremendous gender skew pretty immediately. And why does this matter? Maybe this is okay. It matters to the Python community, and it matters to programming language communities, and it matters to open source communities, and it matters to us as software engineers, because we invest an inordinate amount of time and energy and blood and sweat and tears into correcting imbalances, not just gender imbalances, but other demographic imbalances and socioeconomic imbalances that are starting so early. They're starting well before high school and into high school. So when we look at statistics like this, it matters to me, it matters to these organizations that are trying to undo this misrepresentation, and it matters for a lot of reasons, right? It matters because if we believe that programming is empowering, I believe programming is empowering, it changes the way that you think about the world in a really positive way, it's important for me that we have equal access to this opportunity. It's important because the leaky pipeline affects our community. We have to reinvest down the leaky pipeline in correcting these numbers. And it also matters because we care about the long-term success of the language, or I care about the long-term success of the Python language in particular, because this is also sort of a market opportunity. There's a tremendously leaky pipeline that is tremendously imbalanced, and programming language communities that can figure out how to help correct this imbalance have an opportunity to reach a lot of people who, if they had the exposure, could be really motivated to pursue programming. Okay, that was kind of depressing. What can we do, right? What can we do given that we are dealing with sort of the most gender-skewed subject in schools today? Well, we can take heart in this. Despite the fact that very few girls take APCS generally, that there are entire states where no girls took AP Computer Science in 2013, in Tennessee, almost a third of the test takers were girls. This was actually the highest percentage for any state. And if you had to guess which state would have the highest representation for girls, I don't know if you would have picked Tennessee. I don't know that I would have without looking at the data. But this is true. Do you know why it's true? The reason is this teacher. Her name is Jill. She teaches computer science at a girls' school in Chattanooga, Tennessee. She taught almost half of the girls who took in Tennessee. We're dealing with such small numbers, such small percentages, that one motivated person can totally change the dynamics, can set a record. So if this one teacher can set a record for participation by girls in computer science, what can a global community of people motivated to improve the community and invest in our kids do together? Well, I had this question, and so I asked some experts about it. So I got in touch with some of the most preeminent researchers on computer science education in the United States. And I said, lay it out for me. Like, I want the whole fire hose of ideas. What's on the table for us? What could I do? What could the local user group do? What could our schools do together to start addressing some of these problems? So I'm going to give you the fire hose. And my hope is that at least one of these areas, one of these ideas resonates with you. They don't all have to, but I hope at least one does. So they mapped out 4 big areas for me. The first was policy, and then student engagement, supporting teachers, and then curriculum development. So we're going to run through all of these and see what you think. First up is policy. Did you know that most states don't count computer science for anything? It's an elective. It's an elective. Why would you take it? You're a high school student, maybe even a high-achieving high school student. You are so busy trying to get into the best colleges that you don't have time for crap like this. You would much rather take that other AP class that counts for math or science and is going to help get you college credit as well. So there's a real motivation problem when computer science is only an elective in most states. When a class doesn't count for anything, students don't particularly want to take it. If students don't want to take it, schools don't want to offer it. And no teacher, it's like a dead-end job to be teaching an elective that no students want to take and that nobody wants to fund. Like, why would teachers ever want to get certified for this stuff? So here's a really explicit thing that all of us could do, keeping in mind that California does not count CS right now for anything useful. Something that we could all do is we could pick up the phone tomorrow morning, we could call our state legislatures or call our local school boards and say, hey, we should make computer science count for math or science credit. And we have data on this. People analyze what happens when you make this change, and the states that turn green have higher participation. So making it count for something matters. Here's another problem. People don't even know what computer science is. There's no certification for teachers to teach it. There aren't like standardized workshops that teachers that can go to get trained to teach computer science. Like there's no like global state on how rules are decided for what computer science means or how teachers get certified. And this is a problem because it means that it's like a different process in every county, and every county is looking at every other county and they have no idea what to do and they don't do anything. So for a motivated programmer in the room, the data exists, it's just not aggregated. And honestly, this is like a weekend project for someone with a high tolerance for web scraping and like regular expressions. We could pull the data from all of the states or from all of the counties and coalesce what the rules are, what the requirements are for computer science classes and for computer science teachers and aggregate that into something that policymakers can observe as a collected piece of data. Specifically, here's what would be helpful, or here's what my experts identify would be helpful. An audit of who sets graduation requirements for each state, and then an audit for how teacher credentialing works for each state. And if we had that data, states could look at each other and be much more motivated to make the best choices, to look at what's working and then to emulate it. Here's another problem. This isn't a joke. There's a problem that AP Computer Science is still taught in Java. And I'm not ragging on Java here. Actually, show of hands, who here took AP Computer Science? Some people? Raise your hand if you took it when it was in Java. Raise your hand if you took it when it was in C++. Any Pascal people? A couple of twofers there? Okay, excellent. Right, so the reality is that computer science is taught in a language that computer science teachers hate teaching in. And this is not because Java is a bad language. Java is a great language in many, many contexts, but it is a terrible language for teaching people who have never programmed before. It is very hard to defer very complicated ideas like classes and object-oriented programming. This is not what young people want to do to learn programming, and it's not what high school students want to learn, and it's really not what college students want to learn either. They want to write programs that are fun and do useful work quickly. That the rule that we have for engaging students in high school, which highly correlates to them pursuing some level of computer science in college, is a language that kind of sucks for teaching. And we actually track this stuff. So there was this person whose last name is Reed, who would actually manually, as I found out, every year would call up a bunch of schools and ask them what their intro to programming classes were taught in. And Reed aggregated this data every year. Unfortunately, the most recent data we have so far is 2012. But this is what 2012 looked like. We are still mostly teaching in Java. If we're not teaching in Java, we're probably teaching in C++. But Python has been rocketing up the list. And actually, here's a quote about it. Basically saying what I said earlier. Teachers may still be using Java because it's what they used to use and what they have the curricula developed for, but gosh, do they wish they were using something like Python. Well, what do we do about this? Well, here's the reality. The language that we teach APCS in does change sometimes. What we need to do is teach AP Computer Science, the thing that we need to motivate students in high school to use so they'll want to learn it in college. We need to make it a language that is fun to learn to program in. It should be something like Python. And we could totally apply pressure to make this happen. College Board cares about what colleges teach. They use that, they sort of backsolve from there, like what do colleges teach and what does industry value as languages? And they use those things as inputs into what language they choose to use for APCS. It takes time to make these changes, but collective pressure over a couple of years could absolutely get them to switch languages. It sounds fanciful, but they change it every 10 or so years anyway. It's about time for a change. It's been in Java since 2003. 2003. That is an eternity ago. Okay, we were talking about policy, a bunch of really good opportunities. All of us could pick up a phone tomorrow and call the California legislature and ask for CS to count for a math or science credit. Programming, web scraping-minded folks could do an audit for who sets graduation requirements for each state, or how credentialing works for each state. It would be cool if we had an up-to-date reads list. If Python is rocketing up the popularity, but our data is only as recent as 2012, it would be interesting to know what the data would have looked like in 2013 and what it did look like in 2014. And hey, I don't want to hear that, my kids are going to be doing APCS in Java. That is just going to be a bummer. Let's engage College Board about that. Okay, category number 2, student engagement. And this does kind of tie into the Java thing, but here's the fundamental problem. Students don't know what computer science is, so they don't want to take it. And this is a problem, because by the time you're a junior in high school, you don't actually have that many choices left. You're busy trying to graduate. High school is a really packed in time. High school is almost too late for many people. So the extent to which we can engage kids in middle school and earlier about what computer science is and what programming is, the more likely they are to actually want to try it. So it's important that we support opportunities for early exposure and in places where the days aren't already jam-packed with requirements. And what's cool about this is that there's a lot of infrastructure for engaging kids already, for engaging teens already. There are things like summer camps. Here's an example of a summer camp where these are just software engineers from the community who wanted to get together and engage with students. And the Python Software Foundation sponsored a teen tech camp that would provide the students with Raspberry Pis and teach them a couple of days of basic programming. These aren't teachers, these aren't rocket scientists, they're just software engineers who wanted to get involved in the community. And the PSF can even help you out financially. Other infrastructure that you can, the Girl Scouts and the or after-school programs, which take many forms, but some of the big popular ones are citizen schools and some of the orgs listed on the code.org sort of local aggregated list of opportunities. So if we can take advantage of existing infrastructure for engaging students, we don't have to reinvent the wheel for engaging them. It just takes a couple of hours and motivated teachers who have a little bit of context on what programming is. And it would make a huge world of difference, because if you're not hearing about CS until high school, it's probably too late. All right, number 3, supporting teachers. Here is a sad fact. Think about this. A computer science teacher is typically alone. They are the only computer science teacher at their school with high probability, if the school has any. I mean, imagine if you had no coworkers to engage with about challenges that you're having at work. That would suck. You're busy teaching an elective class by yourself. You probably didn't know how to program before becoming a teacher for this class. That's a very common path. They have math or science. Somebody to rely on for help. But program. A bunch of people in this room know how to program. And some of us may even have experience sort of mentoring programmers or teaching people how to program. We have a community. Teachers don't. Let's help give them a community. Here are just a couple of things that you could do. What do you? Call them up. Say, hey, CS teacher, I would be totally happy to help you review lesson plans. Is there a tricky lab day? I could be a TA. Maybe visit the class. Show them an example of what a real programmer looks like. Invite them to the local user group. We could have a row full of teachers if they're part of our community, CS teachers. Even if there's not one at their school, maybe we can connect folks across the county. But you've got to support the teachers if the teachers are going to support the students, right? Curriculum development. Particularly for folks interested in getting a code on this stuff. First off, did you know that there's a new AP Computer Science? What? It's called CS Principles. And it takes a much broader view of computer science than the old APCS that is pretty focused on like programming fundamentals. It covers a bunch of really good stuff. Abstraction and algorithms and the internet. I love the internet. And why programming matters. And this was developed to be more broadly appealing to a more diverse set of high school students than the original APCS. And this is being piloted right now in a bunch of schools across the US. From a Python perspective, though, this is a really interesting market opportunity. Because while it's great that there's a new APCS that's being piloted, there aren't any day-by for this new class in any language. Now, pretend that you're a teacher, and you're the only teacher, the only CS teacher, and you would like to teach CS principles, and you have maybe 45 minutes a day of planning for the whole day. Are you going to invent a year's worth of material? Like, when are you going to do that? So having sort of off-the-shelf material for teachers to use is incredibly important for the adoption of new classes. And from the Python perspective, I view this as a huge market opportunity to develop a compelling curriculum in a language that's actually fun to learn to program in. I mean, think about this. Here are some of the example lesson plans. Learning about cryptography, visualizing sorting algorithms, using programming to make art. Man, if I were a high school student, this sounds awesome. Like, I would have loved to have been able to take this in high school. It would be a shame if we can't cover these things because we don't have the day-to-day material for teachers to actually implement it. Here's another interesting reality for Python. And here's an anecdote from one of the researchers that I engaged. He was telling me about some of the bizarre constraints that teachers have in like computer science classrooms in typical high schools. And one thing that he mentioned is that there's like a war that happens between CS teachers and IT. And IT doesn't want to give the teachers, certainly not the students, any ability to do anything that might cause problems with the hardware or the software. So they lock down everything. You definitely can't insert anything. Like he told me a story about how they would like glue gun shut the USB ports and stuff like that, so students could not put anything in the machine. You're often firewalled off. You often can't install software. And so this begs the question, in such a sort of hostile computing environment, what resources can you even use? And what this ends up boiling down to is that the only thing that teachers and students could use is the web. And the web is a scary future for Python programmers, because the web is not where Python is strong. But teachers love Python so much that they have gone to inordinate lengths to bring the expressiveness and the simplicity of the language to the web so that they can teach it in classrooms. Introductory program Python text. It's actually written by a good friend of mine, Professor Alan Downey from Olin College. This is a book that install Python on a machine and use it. Some enterprising teachers have actually ported it to a JavaScript reimplementation of Python called Skulpt so that you can go through the Think Python content entirely in a browser. Now this is something that Python is in the browser because this is the environment that the most people can access. You don't have to install anything, you don't have to worry about versioning crap. It's just available for you in the browser to run. This is a big deal, and we should take it seriously. If the future of teaching programming is on the web, I want Python to be competitive there. What's also cool is that this future actually seems awesome. Like, this is material that people use to teach kids, and it's online and open source and on GitHub. Like, the spectrum of ways that this could have played out, free and online and open source, is like a pretty good place to be on that spectrum. So I find this really exciting. And teachers are so motivated that they are doing this work themselves. Which means there's an opportunity for us to help. There are literally bugs. This port, this thing called Skulpt reimplementation. Skulpt is also the massive initiative uses to teach many of its Python classes. Those Python classes have been at least started by hundreds of thousands of students in the past couple of years. Hundreds of thousands of students are using this content, are using this programming framework. And this framework has bugs. If you have ever wanted to contribute to an open source project, gosh, this would be a high leverage place to start. Okay, adding new APC. They're putting a ton of work into being able to use Python on the web. Let's help them. Let's make it easier for them. Okay, policy, student engagement, supporting teachers, curriculum development. That is my fire hose for you. The experts say that these big areas and all of these ideas, I hope at least one sounded fun, because I'm going to call on all of you at the end of this talk to pursue it. So remember, we're atrociously low in most states, but some really good local efforts to make things better. The most gender-skewed class, probably the most gender-skewed subject taught in high schools. It's on us to help make this better. And we have resources. So if you care about Python, I care about Python, the Python Software Foundation can help. We have a bunch of sort of funding opportunities if you need support to go out into your community and help improve the situation. So one thing that you can do is you can run a sprint. If you were really motivated by Skulpt, that online, that JavaScript reimplementation of Python, get together with a bunch of your friends. We'll buy you pizza. Maybe New Relic will host it. Awesome. Let's close out the 50 highest priority bugs so that teachers across the United States can use it. We have an entire kitchen. If you want to get into a school, to be an example of a programmer, to help TA a class, to run a workshop for girls, a workshop for underrepresented groups, we can give you the money and the resources to do this. We also have a general grants program to support sort of miscellaneous items that don't fit into those two buckets. So my challenge for you, having sat through this today, is to pick one of these things. It could be as easy as just picking up the phone tomorrow and calling your local school board and saying, hey, please make CS count for something. Or it could be more involved, but pick one thing and then do it. If everyone in this room, if the dozens of people in this room all did one thing, that would make a real difference. Okay, so here's my challenge to you. Here are a couple of resources that you might be interested in. All of the data that I've used is publicly available, so you can check it out and do your own analysis. And that is my pitch to you. So thank you very much. And this is really the future of Python. It's how we teach it in schools to kids. So thank you. Can I answer any questions?